All right. Okay. Shall we start now? All right. Good afternoon, everyone. Sorry for the 1 hour delay today. I was having an appointment just now. Okay. So we resume our lecture. Last week we have kicked off LU2. LU2 is about probability distribution. And last week we talked about binomial and Poisson distribution, right? So binomial and Poisson are examples of discrete distribution. They are dealing with just whole number, right? And today we are going to move to continuous, one of the continuous distribution. And we're gonna discuss normal distribution, okay? So this one is under continuous distribution. Continuous distribution. Whereas the other two that we have discussed before, they are discrete distribution, okay? So by right, you should know what's the difference between discrete and continuous. Discrete means whole number, continuous means the numbers are continuous. All right, so what we're going to cover today, we're gonna have a look at what is normal distribution, yeah, an introduction to it, and then we will discuss what is standard normal distribution. Yeah, sure. So those who require manual attendance, you just drop your metric number in the chat box. Okay, no problem. Okay, that's the second subtopic, and then we're gonna see how to determine probabilities and percentiles in the normal distribution, and finally approximating the binomial with the normal distribution. Okay, so this is lecture 2. We are going to cover lecture 3, so we're gonna have 2 lectures today. Okay, all right. So an introduction to normal distribution. So when we talk about normal distribution, what should come to your mind is that it should be something like this. Okay, it should be something that is symmetric, or we call bell shape. Symmetric, yeah, symmetric or bell shape. Right. So what is bell? It's like it's a bell. It looks like a bell, and then it is symmetric. It means that it divides equally into 2. So this one is equal to this. Yeah. Right. So what is the difference between one normal distribution to another is the height of the peak. This one is the height. And this is what we call peak. Okay. You should know these terminologies when we are dealing with statistics and distribution. So this part is what we call tail. Tail. This is tail. Okay. So it has 2 tails, and this one is peak. Yeah. Right. So what is the difference between one normal distribution to another is the height and also the width of the distribution. This is the width and this is the height. Okay. Right. The whole thing is called distribution. So you can see that some of the distribution is very wide. The spread is wide, like this one. This is spread, the wide spread. Okay, and then but it has relatively short height lah, not so high. But this one, if you see, the height is higher than the other, but the width of the spread is narrow. Okay, narrow width. Okay, so that is the difference from one normal distribution to another. But you can see that all of them have symmetric and all of them looks like bell shape. Okay, right. Okay, what else? They are symmetric. The area under each curve is the same. Okay, regardless of the type, if you see some of the peak is tall and some are short, but the area under the curve, when we say area under the curve, is this one. The area under the curve. This is curve, right? So this is the area under the curve. So all of this, the total area is equal to 1. Why it is 1? Because it's 100%. We are talking about probability, right? So the total probability is 100%. So in decimal point, we put it as 1, okay? So the area under each curve is the same. So whether it's the peak is high, the peak is low, the width of the spread is narrow or wide, okay, is always, all of these are actually the same, okay. And then the height of normal distribution can be specified mathematically in terms of two parameters, mean and standard deviation. Okay, so what actually differentiates them are the mean and the standard deviation. All right. Normal distribution is the most used statistical distribution. I have mentioned before why it's very common in statistics, because the normality, the trend of normality, it happened in many situations, in physical, biological, social measurement. Yeah. So this is when we talk about any distribution in this world, if let's say the number of the size is, especially when the sample of the size is big, yeah, is more than 30, it will looks like the whole distribution eventually will looks like bell curve or normal distribution. So that is the nature of many distributions that have been observed by statisticians. So that's why they have introduced the concept of normality, the concept of normal distribution. Okay, so and it is actually you know, if you carry out observations, if you carry out research, you will see the same. I mean, you will agree with them actually, yeah, because that is actually, I can say, the nature of the universe, yeah? The normal. All right. So having said that, it is important in statistical inference. So we take into consideration that trend, that normal distribution, okay? And what the statisticians have come up is that they have come up with standard distribution. They have created a table, which is the one that you will refer for normal distribution. So they have created that values and tables, and that is what we can refer to in order to determine the probability. Okay, so in short, what I can say is that normality is important in statistical inference. All right, so there are two parameters that determine normal distribution, which is mean and also standard deviation. See, you can see that in anything, what is very important in statistics is mean, the average, and also the standard deviation. Yeah. Okay, so this one you don't have to worry about this equation, because it's just to introduce you the concept, but we don't actually use this formula. Okay, right. So this is yeah. So just now when I talk about normal distribution, I just say normal. So there is a difference between when we say standard normal distribution. Standard normal distribution is what we also refer to as Z distribution. I think you have studied this in your Form 5, right? Z, normal distribution. So when we say Z distribution, this is normal distribution that have been standardized. It means that we the statistician have put it like the center here, which is the mean, as 0. And they can, I mean, there is a values for each of these, which is actually Z, in terms of the area enclosed by whatever the values of Z. So the reason why statisticians, they have come up with this standard normal distribution, because this one is actually comes with a table, a normal distribution table, where we can refer to that table in order to determine the probability. Okay, so remember, our objective here is still the same. We want to find what is the probability. Okay, so that's why this LU is concerned with probability. Okay, so that's the reason why this normal distribution is standardized, and there is a table. There is a table that is comes with this Z distribution. Okay, let me show the table. return. Okay, so this is the table. So the table, there are so many tables in statistics, if you notice. So every distribution, it will have its own table. So that's why these distributions are called standard distributions, because they have this table made for it. Okay, so you have to refer to the right table whenever you solve the problems related to this distribution. Okay, so if you can see, this is how the normal distribution table looks like. So you have the values of Z. This is the area. Area is actually equal to probability. Okay, so why we want to find the area? Because we want to find the probability, because it is equal. Yeah, but when it comes to the graph, we call it area under the curve, but it represents the probability. So in order to use this table, you should know what's the Z value. Okay, so and the rule of this table, okay, now this one is actually, it just gives you the value on the right side, which means that from 0 to the right. Okay, so this is 0. So for the standard normal distribution, it's the peak or the middle value is 0, and then it's from there it starts with the positive to the right. Yeah, so it's the Z value. Okay, so let's say the Z value is 0.52. Okay, so you have to find, this is the area. So let's say this one, you have to sketch a lot in this topic, because for you to imagine where the area lies. Okay, for example, it's 0.52. Let's say Z. This is Z. Okay, 0.52 is somewhere here. So what does it mean? 0.1985 is actually, it's not that really big actually. This one is, let's say this one is 0.52 Z. So this is actually 0.1985, the values given here. Okay, so it's actually the area under the curve, or the probability. So you should know how to read the table, how to use this table, and understand what does the values represent. Okay, and sometimes you can, for example, you know what's the Z and you want to find the probability. Sometimes it's the other way around. You know the probability and you want to find what's the Z value. So you have to go from inside to outside. Okay, we'll see. We'll have a look at those examples that require that application. Okay, now, so that is the Z distribution table. Okay, so the reason why this one, they just like some of the tables, this is one version of normal table. You can see also that there is a version that gives you both sides, but actually only one side is enough, because this one is symmetric. Okay, we know that normal distribution is symmetric. So once you know, let's say you want to find the area of here, let's say 0.52, and then this one is minus 0.52, and you want to find this area, actually these two areas. So once you got this area, you can just multiply with 2, because it is symmetric. Okay, so that's why one-sided is enough for normal distribution table. So this one is the one that will be given in the exam for you. All right, another thing is, if you see here, the highest value is the highest area, the highest value of the area is given by 0.499. Yeah? This is the last value, right? So it means that it covers actually the whole area of the right side, which is actually 0.5. Okay, if you round up round the values, it's going to be 0.5. And remember that the total area of all the normal distribution is 1, right? So 0.5. If you have the other side, it's actually 1. Okay, so you should know how to use this table, and you should know the rationale of it. Okay, all right, let's go back to the lecture. Yeah, so this is what is meant by that. The total area under the curve must be 1. Every point on the curve must have a height that is at least 0. So you can see that here, it only has the positive y-axis. It starts with 0 to, I mean, the positive values, the height. It doesn't have negative height, okay? All right, so this is the formula. This is a very important formula that you have to apply. Z is equal to x minus mu divided by sigma, which is the standard deviation. Mu is the mean. So what is x here? X here is any value from the actual situation. Okay, so from, let's say we are given any situation, right? So in order for us to use the Z table, we have to convert whatever the values in that particular problem to Z first. So that value is called X. So we'll have a look at how to know what is the X value. But X value is basically the score from the original normal distribution. Okay, so in order to use the table, we have to convert it into Z value. Okay, so that's why this formula is very important for you to refer in order to convert the X to Z value. Okay, let's have a look at this very simple question. A person scored a 70 on a test with a mean of 50 and a standard deviation of 10. Converting the test scores to Z scores, an X of 70 would be, okay, so if this one is not yet, the question doesn't ask yet until, until you use the table, but this is just an example how to convert, how to know what is the X value and how to convert it into Z. So here, this one is actually the X, yeah? And then mean of 50, now we know that this is mu, of course, mu is 50, yeah? And then standard deviation of 10. So this one is the sigma. So, so this is the formula, and then this one is the X, okay? And the Z value here refers to now 2. Okay, this one is not a complete problem or question yet, but basically you are given like a situation like this in the beginning, and then after that there is an extension of it whereby you are required to find what is the area of so and so. Okay, this is just to introduce you the formula. Okay, so now how are we going to determine the probabilities and percentiles? Okay, remember just now when I say that area under the curve is equal to probability, under the curve is equal to probability, and our concern is we want to find the probability. So it means that we have to find the area under the curve, okay? And how we want to find the area under the curve, we have to refer to the Z table. Without the Z table just now, you do not know how to find this area. There is no formula to calculate the area under the curve. It must be based on the table, okay? So that is the purpose of using the Z table. We want to find the area and also the percentile. Okay, let's have a look at an example. Right, find the probability of Z less than 0.45. Okay, in this case, the value is directly given. It's not given the X value. So you can use directly the Z table, but of course you have to know what does it mean with Z less than 0.45. So that's why you have to sketch a lot in order to know where is the area. Okay, otherwise you might do a mistake when you wrongly interpret the areas. Okay, so if let's say Z less than 0.45, so it means we know that this one is 0 and this one is Z. 0.45 is here, 0.45. You just put it, you don't have to refer to the right scale. It's just for you to sketch, just to know where it is. Yeah? So this is 0.45, let's say. So less than 0.45, although this table only gives you the right side, but please don't forget the left side. Yeah, this is the left side. What I mean by here, left, and this is right. Okay, the reason why, because our distribution, it starts with the whole thing here. Yeah, so the whole thing here will give you the total distribution or the 100%. Okay, so that's why we have to refer from the right and from the left to the right. Okay, although in the table we are just given the right side. Okay, so if let's say less than 0.45 just now, it means that the area covers from the negative axis to the right until z equal to 0.45. So that's the area that we need to find out. Okay, right. Another thing is that, okay, now you know that it covers the whole area of the left side. So you have to know by yourself that this one, the total area is 1, right? The total area here is actually 1. So if it divides by 2, then here is 0.5. And the whole area here is actually 0.5. But now it is not 0.5 on the right because it's only until 0.45 for the z value. So it means that you keep 0.45 on the left, 0.5 on the left plus, and this area. Let's say this area, let's say you just name it as y, okay? So y. So what is the y here? So y, you have to find the area in the table, which means that you have to find when z equal to 0.45. So where's the value? So this is 0.4 and this is 0.05. So you match it and this is the value, okay? And that is the area of y, which is 0.1736. So the total is 0.6736. So that's the total area for z, that is the probability of z less than 0.45. Okay. Another way how you want to just cross-check. Whatever the values, the probability that you find out, it should always be positive values. Okay, you see this is positive. There's no negative probability. And also it should be less than 1.0. Okay, so it couldn't be like 2.5, 3.5. So the moment you see that is something like that, there is something wrong with your calculation. So that one is the rule of thumb that you always have to know. Yeah? And also like this one just now, 0.5 just now, that is because you know it covers the whole area. You should know that it's 0.5. That one you have to know by yourself. Okay, so in this case, that's the answer, 0.6736. Okay, now find the probability of z more than 1. Okay, so here, so the area is here, right? Because if you see this one is z more than 1, this is the area. So how you want to find it? Okay, so this one, you have to also deal with lots of logics, right? Okay, let's say here, you know that the area given, the values given in the table, it only covers from the axis to the right. Okay, let's say you have this 1.0 z, the z 1.0. You want to find this area, okay? But the one given to you in the table would be this area actually. So if you refer to the table just now, when z equal to 1, so this one, okay, 3413, okay, 3413. So this one is 0.3413, okay? You know that the total area here is 0.5 and you want to find this area, okay? So logically it should be 0.5 minus 0.3413, that is equal to 0.1587. which is actually equal to this. This one is a bit sama juga lah. I mean, if you find first this one is macam berbelit sikit. This one is more straightforward, okay? So logically, you divide it into two, and then this is the area from the table, and you want to find this one. So you subtract from 0.5 and you get this value, okay? All right, the same thing goes to the rest. It's just about, you just have to do some practices like in order to test your understanding, how to use it, the Z table, and how to know the area under the curve. Okay, another one is Z less than -1. Okay, so let Z minus -1 is here, right? Okay, now you know that it is symmetric, although that you cannot find the area for the left side, but you just find for the right side first. So it means that you find the area from here, and then it is actually equal to the left side, okay, because of this symmetric principle. Okay, here is 0.157. It's actually the same as this question, okay, because for here, this is 0.1587. So it means that it will be equal to the area for Z less than -1, okay, which is this one, because of the symmetric. Okay, right. The last example is this one, -1 for Z between -1 and 1. Okay, so the area is in the middle here. So means that now you know that, let's say you know already from the previous question, this one is 0.157. This one is 0.157. So it means that you know the total area here is 1, isn't it? So 1 minus 0.1587 minus 0.1587. So it gives you 0.6826. Okay. So at the end, it's about logic. Like, you know, you have to think about the area based on the logics. Okay, based on the logics. Okay. So that's area under the curve for Z distribution. Any questions so far? It's just a revision for you, right? You have studied about Z distribution before. Any questions?
No, doctor.
Okay.
No, doctor.
All right. Okay, now percentile. So just now we talked about distribution. Distribution is from 0 to 100. So when we talk about the whole distribution, right, is actually from 0 to 100, or the whole thing here. That's why it's called 1.0, the area under the curve. Let's say it's related to percentile in a way that, let's say we want to know from the distribution like this, okay, we wish to find 93.7 percentile of the standard normal distribution. So it means that the question asks us to find what is actually the Z value first. Okay, that's one thing. And then the second thing, maybe if let's say we have the information of the mean and also standard deviation, the question could also ask what is the X value. So is going backward. Okay, but in this question, we don't have the information of the mean and the standard deviation. So it means that we need to find what is the Z value. We wish to find the 93.7 percentile of the standard normal distribution. So it means that it refers to the area under the curve of 0.937. Okay, this one. So what is the Z value? So this one you have to go from, if you use the table just now, we have to go from the values inside to the outside, because the outside is the Z value. Okay, let's say here. So we know that here is 0.5. Okay, what is the area here? So it's 0.937 minus 0.5, right? Because this one is the balance. So it's 0.4437. Okay, so how to know what's the Z value? So it means that this is the area. Okay, let's refer to the normal table. 437, right? This one, okay. 0.437 Now we have to find from the values from inside. 437. Where's 437? Here. So this is 0.437, the probability or the area. So the value of Z here is 1.53. Okay, so 1.53. So that's how you got the Z value of 1.53. Okay. This one, we wish to find what's the Z 0.96. So the same thing, this one is just the value of this one is different. That's how you got the Z value. Okay. So this one, we wish to find Z 0.04. So which means that it is at this site. So you have to think how you want to find the area, like this one, you know, this one is how much is this. So that's how you apply the logics. That's what I mean just now. So in this case, it's minus 1.75. Okay. All right, this one is okay. So this example, given that the distribution of a dozen IQ scores is normal in shape with a mean 100 and standard deviation of 15. Okay, this one is mu equal to 100, sigma or standard deviation equal to 15. What is the percentile rank of a child whose IQ is 120? Okay, this one is the X value. Okay, X value. So means that in order for us to use the Z table, we have to convert the X value to Z first. So that's why we use this formula, right? This formula. And then we got the value of Z equal to 1.3, right? So from there, we can use the Z distribution table. And what is the percentile rank? Okay, it means that it means this curve. Yeah, so it means that the Z value is here and it covers the whole thing from the left to the right until Z equal to 1.3. Okay, so so it means that we need to find what's the area here actually. Area here. So here is 0.5 and we have to find what's this one. Okay, so what's this one? You have to find when Z equal to 1.3, is this one, 0.4032. So this one is 0.4032 plus 0.5, that's 0.9032. That is in terms of the decimal point. If you convert it into percentage, that's equal to 90.32%, yeah, multiplied by 100. So it means that this rank or this score is actually at the 91st percentile. So when, let's say this is the whole distribution, right? So this person is actually at this one at 91st of the whole distribution. Okay, percentile, you know what percentile? Percentile is the, at what percentage of the whole distribution is that particular point. For example, in this one is 120. Okay. So given that the distribution of a dozen IQ scores is normal in shape with a mean 100, standard deviation 15, is it the same problem? Yes, the same. What percent of the population of a dozen have IQ scores below 90? Okay, now below 90, so this is the X value, right? So that's why you apply it here. And the Z is minus 0.67. So when you sketch it, it is it is because below 90, it means that below minus 0.67, it means that from, I mean, it's before that until it's reached minus 0.67. So this is the area that you are looking for. So how to find this area? This one is negative axis again. So it is actually equal to this side when Z equal to 0.67. So basically you have to find this area in order to make it equal, in order to find this area because it's the same. Okay, so how to find this? This is Z. Okay, let's say Z equal to 0.67. So how you want to find this? This one is, okay, let's say here. This one, let's say name it as A, This one is B. Okay, we want to find what is B, right? So, but what is given to us in the table is the area of A when Z is equal to 0.67. 0.67 is here, which is 2486. A equal to 0.2486. Okay, how to find B? We know that the total area here is 0.5. So B is equal to 0.5 minus 0.2486, which is this one. Okay, so B is 0.2514 or equal to 25.14%. And we know that this one is actually equal to this. So that's why up to here actually is 25%. Okay. So because the question asks what percent of the population, so it must be in the percentage, this one. Right, so that's how you solve it. Yeah? You can see that the area is on the left axis, but because of the symmetry, we can use the principle of symmetry in order to solve the area on the left axis. Okay, another question. The wet X of a metal ingot produced in a smelter is normally distributed with the mean and standard deviation of X being mu 520 and sigma 11. Find the probability of an ingot weighing 525 kilogram or less. Okay, now this one is the X value. Okay, X value. So you can see that the more you practice, the more you know how to solve the problem. And the more you understand the concept of the Z table and the Z distribution. Okay, so it's about practice. Just here to guide you on different example of problems. Okay, so here this is X, right? This is X. Again, this is X. So you want to find what's the probability area under the curve. Okay, it's actually the same from one question to another. It's all about area. It's all about the probability. Area under the curve, right? So convert it into Z first, okay, Z. So that's why you apply this, and it's given to you the mu and the sigma. So the Z here is 0.45. And how you want to know which side to be shaded, you have to refer to the question, like this one. The question asks what's the probability of 525 or less. So it means that although we have converted into Z value, we want to find what's the area on the left, something that is less. Right? So it covers from the left until 0.45. Okay, so you know already this one is 0.5. So you just have to find what's the area here. Let's say name it as A, and you know the Z, this is Z equal to 0.45. And go to the table. 0.45 is 0.1736. So this one is 0.1736, right? So it means that the whole area here, 0.5, 0.1736, that's 0.6736. Okay, that's how you solve it. Okay, I leave the rest of the examples for you to go through by yourself because the pattern is the same. It's just about the tricks, you know, whether it's on the left, on the right, and how you're gonna apply the symmetric principles and the knowledge of the area. Okay. Right. So the same thing. Example 7 and 8. You can try by yourself. And also this one. This one sama juga lah, because this one is actually the X value. Yeah? So you have to convert to Z value first in order to use the table. You convert the X to Z in order for you to use the table. Without it, you cannot refer to the table. You cannot use directly the value of X here. Okay. Right, I think that's it. Normal distribution. In terms of the area and the probability. Okay. So when you see the standard normal distribution, when I say standard normal distribution is the one that has zero value in the middle. So you can see that the standard deviation is, let's say, if you put like whatever the values from the zero, yeah, for example, like here 1, 2, 3. So that is actually the standard deviation. Yeah, so how it differs from the mean. Yeah, okay, so that's why, for example, like if let's say the standard deviation is 1 and minus 1, okay, so this is the area. You can see this one. This one. So if let's say it's 2, then it means that 2 sigma. I mean, yeah, they denote it as like that. Okay. Yeah, that one is just for you to know. Okay, the last part for this topic, approximating the binomial with the normal. Okay, before this we studied about binomial distribution. So in real application, sometimes binomial is not that really suitable to be used, yeah, because of some limitations of it, yeah? Because of the formula, and also the table is not that really practical in some applications. So so that's why we need to use normal. We use normal to approximate the binomial. But in what situations that we can use normal distribution? It should satisfy this requirement. Okay, NP should be equal to 5, more than 5, and also NQ should also be more than 5, and only then we can apply the mean of this formula and this one. Okay, so what is P? Remember when we study about binomial, there is a probability of event, type 1 event. This P, sometimes P is given P 0.35, P 0.4. So that is the P, type 1 event. So the type 2 event is the one that is 1 minus P. Okay, and here we denote it as Q. So Q here is referring to 1 minus P. Okay, so these two multiplication product NP and also NQ should be greater than 5. So if that one is satisfied, then we can use normal distribution to approximate the binomial. And this is the formula of the mu and the sigma. Okay, another thing is the continuity correction, whereby you have to, you have to minus 0.5 and also plus 0.5 from both tails of the range. Okay, we'll have a look at how to apply those things. Okay, let's have a look at this question. From years of observation, biologists know that the probability for any given Arctic tern to survive the migration to its winter feeding ground is only 0.65. You see, the probability for any given Arctic tern to survive is 0.65. So that is P. This is P. P equal to 0.65, type 1 event. Okay, now, a random survey banded 500 Arctic tern. Okay, so N is equal to 500. Use the normal approximation to the binomial to find the probability that between 310 and 340 of the banded Arctic tern will survive the migration. Okay, so this is the X value, actually, the X. Now, they ask us to use normal approximation to binomial, but we have to first find out whether it meets the requirement or not, which is NP and NQ. What's the value of NP and NQ? So here, we know that P is equal to 0.65. What is Q?
Minus 0.65.
Say again?
Q is 1 minus 0.65.
1 minus 0.65, yeah? Okay, that's 0.35. Okay, N is 500. P is 0.65. So if we find the values of this is 325, which is greater than 5. So it means it satisfies the first requirement. The second one, NQ, 500 times 0.35, that gives the value of this, 175, is also greater than 5. So it means that it satisfies the requirement. We can use the normal approximation to the binomial. Okay, now that's done. And then what else that we have to find? We have to find what's the, given this one, the mu and p. We have to find the mu because it's not given the mu or the mean. Mu is np. So n is 500. And also the sigma, which is equal to npq, the square root of npq. So in this one, 500 times p is 0.65. So that's 325. The mean is 325. And then for the sigma, square root of 500 times 0.65 times 0.35, that's equal to this one, 10.67. Okay, that's the value of sigma or standard deviation. Okay, so that's actually step 2. Okay, step 2. Step 3. So now we know the range is between 310 and 340. This is the range that the range of x that we want to find the probability. So it means that let's say x is between 310 and 340. So this is the one that we have to subtract minus 0.5 and also plus 0.5. So means that now the continuity correction, remember this one, continuity correction, we have to subtract 0.5 from the lowest limit and plus 0.5 on the highest limit. Okay, so now the x, it should be 310 minus 0.5, that's equal to 309.5. And then for the upper limit, it's 340 plus 0.5 equal to 340.5. Okay, so now that is actually the x value that you want to find. Yeah, but now this is x, right? So in order for us to use the z table, we have to convert x value into z value. So each of these you have to transfer to z value using the formula of x minus z divided by the sigma. So we know that this is the sigma and this is the mu that we have to find out. So just apply 309.5 minus that. Okay, and then on the left, on the right side, 340.5 minus this. So you got this range, minus 1.45 and 1.45, and that is the z value. So from there, you can start finding the area. Only then you can find the area, right? So let's say 1.45 z, and it's equal to here, minus 1.45. So you have to find what's the area here, actually. Okay, so this area, if you refer to the table, 1.45 is this one, 4265, 4265. So this one is 0.4265. So you just multiply by 2, right? 0.4265 because it is symmetric. So the answer is 0.853. Okay, so this one is another way how you, but this one is more straightforward and more understandable. Yeah? So it's just that you find one side and then you multiply by 2. Okay, so that is the probability that you want to look for at the end. Because the question asks you to find the probability. You can see the question asks find the probability. So this is the answer. Okay, so that's how you approximate the normal using approximate the binomial using normal. Okay, so first check the condition NP and Q, and then subtract 0.5 on the left point plus 0.5 on the right point, and then find the z value of both sides, and then find the probability, find the area, and that is the probability. Okay, so that is z distribution. So basically we have covered what is standard, what is normal distribution, what is standard normal distribution, which is the z is also equal to z distribution. Sometimes we call standard normal, sometimes we call z. And then determination of probabilities and percentiles, and finally approximating the binomial with the normal distribution. Okay, can we have a break? 5-minute break before we proceed with lecture 3. Any
Okay,
question
doctor.
on this?
Yes,
Okay,
doctor.
doctor.
Any question on standard normal distribution? Please practice by yourself
doctor.
the questions so that you can understand better. Yeah, since statistics is a maths course, so you cannot avoid from practicing in order to make you familiar with the concept. Okay, we start again at 12:56. 12:56. Okay, guys, we continue. All right, the
Okay,
second part
Doctor.
for today. The second part for today is sampling distribution and central limit theorem. Okay, so there are two things, two subtopics. First, we're going to have a look at sampling distribution first. So what is it? And then the properties of sampling distribution of sample means, and finally, the central limit theorem. So that's the outline for this second part. Okay, now what is sampling distribution? So a sampling distribution is a probability distribution of a sample statistic that is formed when samples of size n are repeatedly taken from a population. Okay, now before this, I have introduced you the concept of population. It has samples, right? But this one is really, when we talk about sampling distribution, is related to a situation whereby you have a population, and of course you have things inside it, yeah. But then whenever you keep taking samples, I mean, like repeatedly, you know, like you take samples from the population, take samples in order to kind of like give some, I mean, in order to give some values of something. Yeah? So whenever the action of taking the samples and taking the data actually repeatedly, and whatever the data collected from that is called sampling distribution. Okay, I think you will understand better after this, but that is at this point for you to accept what is sampling distribution. Yeah? It represents data that comes from the samples that are taken repeatedly from a population. Okay, so that's sampling distribution. So let's say you have samples consisting of the data, the point, what the values, okay? And every sample, it has the mean value of the sample. So let's say we are now, our samples is the mean of those samples. How to say that? It's a bit redundant. So when we are talking about the means of those samples, okay, the situation is referred to as sampling distribution of sample means. Okay, sample means, right? This one is, let's say this one is our data now, our main data. Okay, so that is meant by sampling distribution of sample means, because the means come from each of the sample. Yeah, and it is represented by the value of x with bar. Okay, x1, x2, x3, and so on. Okay, so properties of sampling distributions of sample mean. So the mean of sample means, okay, so because of this one, right, mean of the sample, this is, each of this is sample mean, we call it. The average of this, if I don't want to use the word means because it's a bit redundant, the mean of each, the mean of all of this will equal to the population mean. Make sense? Because we are having all the samples in a population, right? So the mean of all the sample mean is equal to the population mean. Okay, so that is meant by this one. The mean of the sample means is equal to the population mean. So the symbol for the population mean is mu alone, but for the sample means we have mu and then with the subscript x bar. Okay, this one is subscript, yeah. And then for the standard deviation of the sample means, the sigma x bar is equal to the population standard deviation, which is this one, divided by the square root of n. Okay, so that is the formula of it. Standard deviation of the sampling distribution of the sample means is called the standard error of the mean. Okay, you just accept first. Let's have a look at this example in order for you to understand better. Right. So the population values 5, 10, 15, 20 are written on slips of paper and put in a hat. 2 slips are randomly selected with replacement. find the mean, standard deviation, and variance of the population. Okay, so the mean is quite straightforward. Let's say, okay, this is the values of that is available, that are available in the population, right? The mean is 5 plus 10 plus 12 plus 15 plus 20 divided by 4, you got 12.5. And then this one is standard deviation. Remember the formula, there is a formula for the standard deviation. Where's the formula? I don't have the formula of standard deviation. Where is it? But there is a formula that you have, I think you have come across, the standard deviation and the variance. Okay, but it's not shown here. But that's how you got these two values based on the S square. There is some, I don't remember the formula, but the S square and the S is standard deviation. And so that's how you got these two values. Okay, now the second part, okay, this is just the probability histogram, just to see how those things are presented. I think the main part is here. Okay, list, it says here in the question, 2 slips are randomly selected with replacement. It means that represents the sampling distribution. It means we know that the population has all of these values. Okay, let's say we imagine that we want to have samples taken consisting of 2 values. Okay, so that samples, it can be, you know, various combinations of all these numbers. Okay, so we go directly into question here, this one. So list all the possible samples of size n equal to 2, because the question asks n equal to 2, and calculate the mean of each. Okay, so now we have the values, possible values 5, 10, 15, and 20. Okay, you just imagine that those are the values in the population. And if let's say we take randomly one value and then one value again and make it as one sample, so we can have many combinations, many possible combinations. So these are all the possible combination, this one. So it starts with how you want to know all the possible combination. You just imagine all the possible, you just list down all the possible combination. For example, 5 and 5, 5 and 10, 5 and 20, until 5 and 20. Yeah, you just list down everything. Yeah? Start, and then again, start with 10, 5, 10, 10, 10, 15, 10, 20, 15, 5, 15, 10, and so on until 25, 2010, 2015, and 2020. So that's all the possible combinations. And you can see here, the order plays an important role. For example, like we have 520 and we also have 25. So it's different, and we count it as a different sample. Okay. Yeah, so altogether, these are all the possible combinations. And for each of these sample, we can find the mean of it. Okay, for example, the mean of 5 and 5 is 5, 5 and 10 is 7.5, and so on. Okay, so you can see that every sample here is, each of these represents sample. Yeah, and it has the mean value. Okay, so this is an example of sampling distribution. Okay, I hope that you understand better what is sampling distribution. We have these values initially in the population, and if let's say we take samples from the population, it can be various combinations of those values. Okay. All right. So here is the sample. Yeah, the same thing actually. Sample mean is just to write down again. Now, our x value is the sample mean. You can see that here, these values is the one that we are concerned with. So we put it as x bar, this. And then f is the frequency, how many times it occurs. Okay, for example, 5 occurs once, 7.5 twice, right? Okay, 2, 10 3 times, so that's why it's 3, and until it's 20, only 1. Okay, so that is frequency. And then probability. So remember when we studied about the frequency distribution table before, or the relative frequency, how to find the probability, how to find the relative relative frequency and all this. Yeah? So the probability is equal to, let's say this one is the total n, the total f is 1 plus 2, 3, 3, 3, 6, 6, 4, 10, 10, 15, 16. So n here is 16 if you sum up all the f. So the probability here is equal to 1 over 16 equal to 0 0.0625. Okay, so this one is equal to 2 divided by 16, that's 0 0.125. Okay, and so on. So that is the probability of each of the sample mean. This is sample mean. Yeah. Okay, probability distribution of sample means. Okay, so what else? This one is just how to present it in the form of histogram. I think, yeah. So the question will look like, okay, so that is sampling distribution, okay. Now let's move to central limit theorem. Okay, this is another subtopic. And normally the question will be combining sampling distribution and central limit theorem. So we'll have a look at the question at the end. Okay, so we cover this one first. So central limit theorem. So what is this? So if a sample size of n equal or greater than 30 is taken from a population with any type of distribution that has a mean mu and standard deviation sigma, the sample means will have a normal distribution. Remember when I said before this, I said briefly that any distribution, especially when the size n is big, when I say big is, let's say, more than 30, it will be likely to follow a normal distribution. Sometimes, I mean, most of the time. Okay, so when it is more than 30, there is a high tendency for the distribution to look like a normal distribution. So this is actually one of the theorem in this concept, in this central limit theorem, right? So it means that if, let's say, we do not know any, whether we don't have any idea normally, let's say I carry out a research on distribution of height of students in Faculty of Resource Science, and my size of samples may be 50. Okay, so looking at the n equal more than, it's already more than 30, like the n's of my sample is 50. So I have an early idea that at the end, the distribution will look like normal distribution. So it means that the majority of the students will have the height of in the middle, and very few will have short height, and very few have very tall height. Okay, because it will follow the normal distribution. So that is what, you know, like if, let's say, we want to carry out any survey or any research, we have to consider that n, and we have to remember this theorem. Okay, and when people say this, why they come up with this n equal to or greater than 30? Because it's based on many observations, maybe 1,000, more than 1,000. The statistician have seen that maybe 90% of it follow the normal distribution. So that's why they conclude this this theorem. Okay, so that one is when the n is greater than 30. Okay, regardless of whether I know about it yet or not, it will eventually very close to the normal distribution most of the time. Okay, so that's one of the theorem. And the second one, if the population itself is normally distributed with mean, mu, and standard deviation. Okay, just now, this one, I do not know, right, whether what kind of distribution it is, but I will assume it as normal distribution based on the n, which is more than 30. But the second condition here, if the population itself is normally distributed, okay, let's say you have an idea about the shape of the distribution. You know that it is normal. Let's say even though the n maybe less than 30. In your case, it's let's say n20. But accidentally, the shape looks like normal, even though it's less than 30. So in that case, the sample means that is, let's say the population is normally distributed. It means that the sample means will have a normal distribution because it is related to the population. If the population is normal, of course, the sample mean is normal. Okay. Although in this case, the n may be less than 20, let's say, if let's say n is less than 20, but if you have an idea about the pattern of the population distribution, which is normal, okay, apparently the sample means distribution will also be normal. So that is the second rule. Okay, this is the second one. The first one here is n equal greater or equal to 30. Okay. Right. Let's say if you, there is a situation where the n is less than 30 and you do not know what kind of distribution of the population, whether it's normal or not normal. So in that situation, you may not may not have any early idea about the sample means. It could be normal, it could be not normal. Okay, so it's just that it doesn't satisfy the first and the second rule. Okay, so how are you going to apply this understanding in the question? Okay, so but before that, the central limit theorem says that if let's say the situation satisfy the central limit theorem, so the mean of the sample means, this one is the means of the sample means, will be equal to the mean of the population. Okay, that is the assumption. And then the second one is in terms of the standard deviation of the sample means. Now we talk about sample means, it will be equal to the standard deviation of the population divided by the square root of n. Okay, that's how you could find this and this. Okay, so let's have a look at the question. So how to apply those theorem and also the our understanding in sampling distribution. So given to you this problem, the heights of fully grown magnolia bushes have a mean height of 8 feet, and a standard deviation of 0.7 feet. 38 bushes are randomly selected from the population and the mean of each sample is determined. Find the mean and standard error of the mean of the sampling distribution. Okay, now this is the only information given. The rest here are solution actually. This one is solution. Okay, so how to digest the information from the problem? So now you see here, the heights of fully grown magnolia bushes have a mean height of 8 feet. So it refers to actually the whole area. I mean like the whole big area, which we can refer to as a population. Okay, so this one is actually the mean of population, 8. And then standard deviation is 0.7. Okay, let's say this is population. Standard deviation is 0.7. And then 38 bushes are randomly selected. So now you see this is actually the samples. The number of samples are 38. And you can see that the n is greater than 30, right? So now you can see that it satisfies the central limit theorem. So means when it satisfies the central limit theorem, we can apply the rule saying that the mean of the sample means, is equal to the mean of the population. So now we know that the mu x here, this one, is equal to 8 because of it satisfy the central limit theorem. Now the standard deviation, we can apply this formula, and this value refers to the standard deviation of the sample means. Okay, now because our concern now is the sample means. Okay, I hope you can get it. Okay, find the mean and standard error. So that's the only question, mean and standard error. Okay, let's have a look at what else here? Find the mean, and yeah, I think that's the only question. This one is just additional. Okay, let's say there is a question, an extension question. Find the probability that the mean height of the 38 bushes is less than 7.8 feet. Okay, this is where you have to find the probability. Find the probability less than 7.8 feet. Okay, let's say here. So you have to sketch. Initially, it's not, you are given like an information of X actually. So less than 7.8. How you want to know where to where? Because 8 feet. Yeah. So this one is 8. This one is the mean. So 7.8 sits on the left than the 8. Okay, so find the probability that the mean height is less than 7.8 feet. So it means that the area here actually. Okay. But here, this one is not Z yet, right? So you have to convert it into Z, right? Okay, let me show here. So Z is equal to X minus mu divided by the standard deviation. So let's say X is 7.8 minus mu just now. Our mu is 8 and 0, okay. Mu is 8. The sigma is 0.11. Right. 8 divided by 0.11. So that gives the value of minus 1.82. Okay, minus 1.82. So means that, okay, this one is not the standard, this one is the not the standard distribution yet, standard normal distribution yet. So the Z value is minus 1.82. If you want to sketch the Z distribution, this is actually how it looks like. This is 1.82, the Z. Okay, so it's actually this area. Okay, so from here you can apply the same principles that you understand in the normal distribution. So in order to find this area, you know that it will be equal to the right side area if the Z is equal to 1.82, right? So in order to find this area, you have to find first what's, let's say, this area. Let's say A, yeah? Name it A. So here is actually, let's say if we refer to the Z table and find 1.82, this is the one, okay, 1.82, 4656. Okay. So A is equal to 0.4656. 4656. Okay. So this one, the whole area, we know that 0.5, right? So let's say this one is B. B equal to 0.5 minus A. 0.5 minus 0.4656. That's equal to 0.0344. Okay, so B is 0.0344, and that means that is also equal to here. Okay, so you answer this one actually here. Okay, understand? So that's how you find the area of the probability, actually, the probability of the mean height, which is less than 7.8. Okay, 7.8 is X value, then convert to Z first, then find the area, and that is the answer. Okay, I hope that's clear for you. Another example. The average of a statistic test was 78 with a standard deviation of 8. If the test scores are normally distributed, find the probability that the mean score of 25 randomly selected students is between 75 and 79. Okay, here you can see that there is an information given to you if the test scores are normally distributed. So it follows the second rule of the central limit theorem, which is this one, yeah? If the population itself is normally distributed. So that is the second rule. Just now, the first rule, and the first problem just now, because it's more than 38 bushes, so it satisfies the first rule. Okay, so this problem satisfies the second rule. The test scores are normally distributed. And you can see that the information given here are 25 randomly selected. So even though this one is less than 30, but because of it has this information that is normally distributed, so we can apply the central limit theorem. Okay. So this one is actually the same thing. Like you just apply all the knowledge that you know. Yeah, you have to find the probability or the area between 75 and 79, and then you have to convert these two values into Z first, right? And then find it in terms of the Z distribution. Okay, I think that one is quite the same principles. Yeah, at the end you'll find this area, which is this one. Okay, but I just want to emphasize this one just now tadi. Macam mana you apply the central limit theorem, how you want to actually equate this thing, because that will be needed for you to find the Z value. Okay, all right. This is another example. Okay, I don't go through everything, but just to say that this one satisfies the central limit theorem because of this information. Sample of 50. It doesn't say that it follows normally distribution or like how it is mentioned for the previous problem, but because of this one, so you can use the central limit theorem. The rest is the same, how you find the Z, how you find the P. Okay, this one. This one, it doesn't say that it follows normal distribution. You cannot apply the second rule. The first rule is also not applied because this one, this word. Find the probability that the salary for one randomly selected mechanic is greater than 35,000. So here we just talk about sample, one sample. So it's obviously less than 30. So in this case, you cannot apply the central limit theorem. Okay. And what it means that, so this one, you just use the values of the things given for this one. So that's the difference between those problems that follow the central limit theorem or those that doesn't. Okay. Okay, the rest is all the Z value and all this. Okay, so that's central limit theorem, and also the sampling distribution. Okay, so in this second part, we cover what is sampling distribution, what are the properties of it, and also the final part is central limit theorem. But the problems normally combines both concepts where you have to understand both. All right, that's it for today. So in the first part just now, we cover normal distribution, and the second part here, we cover sampling distribution and central limit theorem. Okay, any question? I will post the tutorial 1 and also tutorial 2 after this, inshallah. So have a look at it on eLeap. And try to, for tutorial 2, even though that we are not yet, we don't finish yet LU2, but for any questions concerning those topics that we have covered, you can attempt it. Because at the end later, I would want you guys to submit before the mid-sem exam so that I have some time to go through and give feedback before the exam so that you can do a revision. So in order for you not to be too stressed out later on to do the whole question, so you just attempt those questions once we have covered the topic, then you can start doing the tutorial. Okay, I'll post the questions after this. All right, so that's it for today. Thank you very much for your attention. If you have any question, you can email me. Okay, you can ask me by email if you don't want to ask now. Yeah, so I'll post the lecture notes on eLeap and also the recorded lecture. And also those who need the manual attendance. Okay. Yeah, those who have scanned your attendance, you may leave now. You can leave now.
Thank you, Doctor.
All right.
Thank you, Doctor.
You're
Bye-bye.
welcome.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Yes, welcome.
Thank you, Doctor.
Okay.
Doctor, I want to scan.
Okay. Wait, hold on. What's your name? Siapa tadi?
Saya nak scan.
Tak apa, I can do it because I have the list of names here. Are you Ahmad Sofyan?
Yes.
Okay, okay. All right, done for you.
Madam, I need manual attendance too because I'm using phone.
Okay, what's your name? What's your
Fadilatul Aisha.
Okay. Okay,
Thank you,
done.
madam.
Doctor,
Yes?
I said thank you.
Okay, yeah, welcome.